guys. I don't know if you know me or not know me or whatever. My name's Kelsey Rangel, graduating senior here at Sonoma State. I'm really excited, but gonna be bittersweet, gonna miss y'all and everything. But here's my presentation on energy-aware scheduling in high-performance computing. Basically, how can we make supercomputers more efficient in energy? So what is a supercomputer? What am I talking about? Well, a supercomputer looks kind of like this, large, and has a lot of, hard drives, able to do a lot of computation, things like that, used for like engineering and scientific mumbo jumbo, as it were. So basically, you have this large machine that allows you to do multiple tasks over, a course of, a section of time that's shorter than a normal computer would let you do. But if we want to do it, we also need to make sure that we schedule each job correctly. So what am I talking about when I talk about scheduling? Well, you all know what a class schedule looks like. We're trying to schedule, a class during a specific day for a specific time. Well, for a computer, it's not much different. We want to make sure that we schedule a specific task for a specific maybe processor or machine that works best for it, so that we get the best time or energy out of it. So basically it's kind of similar in that, but for us, what we wanted to do was make it so that not only that we are doing something where we make it so we don't just do one at a time. We want to figure out a way to make it so we can do multiple tasks at different times, but we have different tasks. So here we have like a little Tetris kind of visual, where we have different jobs that require something at different times. So what's the best way to configure a task with our machines that we're allowed to, utilize what we're given and to make it not take as long as it would? So we have a bunch of patterns in tasks. So if we have a bunch of jobs that we do, then we can figure out like maybe a job is taking the same thing and it has a pattern to it. Then we can basically notice the pattern of similar jobs and assign it to the best machine for it. So that's kind of similar to what we're doing here. We have task A, B, and C, and they all look kind of similar to what they're doing. So if we're given an unknown power trace, which power trace is what, you take a power signature every second of a job. So every second you take the wattage that it's taking up, and we take this trace, we notice from a statistical point of view what characteristics it has. And so we say, okay, well, this unknown trace looks like task C. So whatever task C is best on, whatever machine it's best on, I'm going to put that unknown trace on that machine. So then we have to schedule our tasks, right? So for me, what I started with this semester was modifying the scheduler to make it better than it is, or was rather. So the scheduler was initially set up as first in, first out. We basically, what it is a job comes in and it goes out. A job comes in and it goes out, and that's all it does. It would schedule either random jobs, so just pick randomly from a set, or it would order them from lowest energy and do those first. We had 3 different machine types where we had alpha, beta, and gamma, and then alpha and gamma machines could also then be split into 2 separate machines to make it. We noticed that by splitting them in 2, they allowed us to do specific tasks on those machines that would allow us to run it a little bit faster. So, as I said, FIO, you have one coming in and you just keep going. Well, as you can see, you have time happening here, which is fine, but the processors that we have aren't being fully utilized. There's some here during job 2 that is sitting kind of idle, right? So we want to be able to use everything we're given so that we don't waste our time and energy. So basically, we went over, in the beginning, we wanted to see what would happen if we took away machines. What happens to our power? What happens to the energy? What happens when our machines get taken away from us and we have the same amount of jobs? Well, I first started with doing the lowest energy policy. I figured doing random wasn't really going to do too much for me, so I just did the lowest energy policy, and I started with 10,000 jobs. And each time I scheduled a run, I just removed half of the machines to see what would happen. So I found when I ran it to gauge what happened to a certain machine type that alpha 1, 2, it spikes in energy right there. So if I have I think it's 98 machines of alpha 1, 2, then I'm using a lot more energy. So I need to be careful what happens if I am constantly putting tasks on alpha 1, 2, where I can also best use them on alpha 3, 4, or any of the other machines that can be used. So if I have some high priority jobs, I want to put them on alpha 1, 2 because sometimes it works the best. But what if I have a low priority job and I don't want to put it on alpha 1, 2 because it works, but I need to save that for my higher priority. So I'm going to put those maybe on my gamma or my alpha 3, 4, just to save machine types for the ones that I really need, because I don't want to use up too much energy if I lose my machines. So I was going to do something where I have to parallelize it, so that I have jobs that go on different, cores in the scheduler, not just one core at a time. So I changed the scheduler to allow that, but that not only allows me to, parallelize it to have a job get done faster, but I also need to think about how am I going to schedule each job with each processor. Well, I found this concerted backfill algorithm, which allows you to take a high priority list of jobs, schedule them, and then should there be any blocks like we had with job 2 earlier, we can schedule some low priority ones to happen in this area as well. So we're getting more done, but not, because we're getting more done, and not wasting resources. So I was able to get more jobs done in a certain amount of time by doing this algorithm. So the idea behind it is you create a linked list of the free processors. It's constantly updating this profile. So what's great about it is, let's say you have a high priority job. It takes a certain amount of time. You kind of know this from the task. It's kind of run a lot of times, and you see a pattern happening, like we noticed with the power traces. So with this, you notice that this job was done sooner than we thought it would finish. So what's great is, as soon as a processor gets freed up, we can say, okay, in this list, is there another task that we can fit in this slot so we're not wasting our resources? Can we fill this area without, wasting time? So if a job has a possibility of being run sooner, it's moved forward and reinserted the profile. But if we keep looking at the profile, then, and there is no area to put it in, it'll get rescheduled. So that's what's great about this algorithm. So basically, in conclusion, with the original scheduler, you had FIO. So the resources are there, but they're not being fully utilized. And with backfill, you have the resources fully utilized. You have the time and energy that you're saving because you're using everything that you've been given. So, yeah.
Questions?
Okay. Yes.
For the jobs, are they unique, or can you take a job and split that among the other processes as well?
Not among different machine types, but you can split it among the different cores in a machine. Yeah.
What were some bottlenecks when you were trying to optimize the backfill algorithm?
Well, I haven't fully finished that one yet. Yeah, that one's still in a work in progress. Yeah. But I will let you know as soon as I know.
Thank you, Kelsey. Arthur, you're on the ding. So Arthur, this time with other collaborators, is going to talk about the scheduling algorithm that I sent out to you all, to the CS majors. So he's going to talk about it, its development, the collaborators, and some of the insight into it.
Oh, that was trippy. Hi, all. I'm Arthur again. I'm going to talk to you about the S2 scheduler. I presented last colloquium, last year, about kind of the progress we were going towards and how we were working with the searching. So for this presentation, I'm going to focus more on some of the technologies that we use. So just to give a brief overview of exactly what the scheduler is trying to do. It's trying to help you search and browse classes and courses fluidly based on what's actually available rather than going through a catalog. And it's also helping you to generate some valid schedules rather than using PeopleSoft, where PeopleSoft, there's a high cost for generating schedules and finding conflicts because it has to make requests every time. So the technologies that we use for the scheduler project, we use Meteor, which is a reactive node-based web server. It's kind of like an application package. So it really helps you push out reactive, dynamic web applications. And Meteor comes packaged with a couple technologies I thought were pretty cool. It comes with Blaze, that's a templating engine, so it allows you to make HTML templates and then do data binding between kind of the data underneath and the templates. So that's pretty sweet. And then you also have MongoDB in the background, which is really integrated with Meteor. And it's cool how I'll talk to you about how it's integrated. And then we're also using a Ninjix production web server. So similar as for API, we have Ninjix running, we have the node server running, and it's doing port forwarding. So some of the reasons why we use Meteor is one of the core principles of Meteor is reactivity. So reactivity means in this context, when something changes, it's reflected automatically and dynamically without thinking about it and without having to actually explicitly bind it. So a way this is exhibited in Meteor is you actually have a local client database on the client. You have a client database and a server database that communicates data back and forth. If you were to change the entries on the server side, that will get dynamically pushed to the client without you doing anything. And that's one of the principles of Meteor. So along with that reactivity, there's Meteor Accounts, which is an account system that Meteor comes packaged with, which is it's great because we really wanted to focus on producing something, not having to write some of the components that are really kind of tricky and dealing with data going back and forth between the client and server. And the way you deal with data going back and forth between the client and the server is through something called subscriptions and publications. So I'll talk more about that. So Meteor subscriptions, the way it works is that on the server side, you have your Mongo database running, and you have collections within the database, which a collection is synonymous to a table. It's synonymous to a table in SQL, so we all should understand that. So you set up subscriptions to collections that that clients can actually subscribe to. You give them the terminology, right? You publish collections for the clients to subscribe to, and the clients subscribe to the things you publish, and the data between the server and the client is dynamically pushed using Meteor's reactivity, using something called GDP, which is Meteor's way of connecting the client and the server. So kind of continuing the project on, we're really hoping to get some filtering going. And I'll show you guys an example soon. But filtering right now isn't implemented, but we want to be able to say, I want a course on Friday. I want courses only on Friday, say like after 8 p.m. That'd be something great. We'd also like to have more details about a course and other classes that make up a course. So right now it's at the class granularity level when you do searching. And then also further integration with other SSU products like the iOS application and potentially into the Seawolf portal. So I'll give a quick demo just how the scheduler helped me for my final semester coming up to prepare for my course. So I'll trust no one's going to steal that. So right when you go to the scheduler, you're presented with the search page. It was kind of something we really wanted to have available right from the beginning and show to everybody. So here I'm searching for all upper division CS classes, and I want to take game programming. Let's see. Parallel computing. Artificial intelligence. Now, kind of this use case it's kind of really basic, and it doesn't really show the power of the scheduler. More of the power revolves in, I also need 1 unit of a GEC, which is kind of a weird number, but they actually offer 1 unit courses, so you can actually do C1 unit. And now this lists all the offered GEC 1 unit courses that I could use, and I could add every one of these courses into a slot over here. And from here, I have the classes that I want to take defined. So once I generate the schedules, it actually tells me that there's 4 potential schedules, and of those 4, only some of them are going to be valid. So here, this would be the Form in Law, Ethics, and Society, the actual schedule I'd be agreeing to. Or I could go with, this one's kind of interesting, it's an arranged time, so it's not exactly accurate. And this is the actual schedule that I'm actually going to take next semester. So it allowed me to very easily see all the general ed courses that I wanted to take and compose them into a schedule. And then from there, you just take the ad codes and you go right to PeopleSoft. So really, you hit PeopleSoft once with the ad codes and it sets up your schedule. I was really surprised how fluidly it worked. Yeah, any questions?
Do you have any chance for error?
Chance for error?
Yeah, I know it's connecting and it's pulling all the most of the database the data from there. But is there any chance of error?
I'm not totally sure. I would imagine this is kind of on Meteor's side. Meteor really wants to pull away connecting the client and the server, so it becomes kind of magical in how the data actually gets from the server to the client. So actually checking for errors is more on the Meteor side. You would hope that they've implemented their systems to account for that and then resubmit or re-request.
I guess the reason I ask is because if people are gonna rely on this service, I guess it's if somewhere along the way it makes a mistake or something like that.
Yeah.
Yeah, exactly. And then it's kind of
yeah, there is definitely a disclaimer that it's a helpful tool to help you build your schedules, but it is in no way can replace PeopleSoft completely or concretely say this is what's going to be true. You have to take it with a grain of salt, of course. But, that is unfortunate, but having the accessibility of the courses is really great.
I'd live with any error because you can say, all right, what are what-if schedules, right?
Yeah.
You can't do that now. You want to do what-if, get out your pencil and paper. Yeah.
Exactly, yeah. The alternative methods is quite cumbersome.
You can always check those real quick in PeopleSoft. Oh, yep, this is good. I'm good to go. These classes aren't full.
Yeah. Sir?
Is there any, on the app, is there any tutorial or frequently asked questions in best use for search terms or anything like that?
I will show you. Oh, nope. Sorry. There actually is. There is an About page which outlines some common uses or common use cases or queries that you can perform. That is kind of moving forward, something we need to work on, kind of getting these esoteric kind of search terms are not really well understood, getting that to the forefront to common people. So really we want to have these keywords to be available for power users, but we also kind of need a way to pull it to people who have just seen the system and be able to use it. So that's definitely some active work that needs to be done.
But one of its major strengths is that search engine.
Yeah.
However you do it, whether it's verbose or just using the abbreviations, it's something that really PeopleSoft lacks. Just the ease with which you can search for entries. And the question of James' question of whether this is ultimately this is a system just like any other system. You develop it and you debug it. There's no question that systems do have potentially have bugs in it. But over time, you increase the confidence, just like in PeopleSoft. PeopleSoft has a lot of bugs as we speak. Still.
Any more questions?
Is that capacity live?
That capacity right now, there are plans that to potentially make it live, but actually interfacing with PeopleSoft in this piece of software, it's very challenging. The connecting to the software is not challenging, but constantly updating it, make sure it's valid, and make sure it doesn't invalidate anything would be very difficult. So it's kind of in the process, but it has a capacity to be live.
So how often is that?
It would depend on a person actually gathering the PeopleSoft data and submitting it to it, because it's not available just dynamically from this application, to my knowledge.
So how this data has come about is we have queries that we run on PeopleSoft, and you have to physically run that query and get the results, and give him the results so that he can upload it, just like really the previous presentation that Kyle and Arthur. So these are kind of all done by hand, and therefore updating the seats. So what they now have is at least it tells you how many seats are available for that course, not how many are left and how many have been taken. But like Arthur said, to make that to kind of synchronize with PeopleSoft, given that the appointments are every hour, you have to update this every hour. Just extract the numbers from PeopleSoft and load it here. And you'll be right kind of within a margin of error, of course.
Thank you very much.
Mark. So Mark McKinney.
Do you remember? So the way I found this internship was actually specifically through Indeed.com, and you can specify exactly what you're looking for, what major you are, and they'll list companies based on area that are hiring what you are. And so I found PG&E, and I thought it was awesome because it was located in San Francisco, and I really wanted to work in San Francisco. I'm sure all of you do. And so it was the first spot I applied to, and it was the first callback I got, so I got really lucky with that. But they didn't call me back instantly. Like, summer had started, and it had been a week or two, and I thought I wasn't going to get a job, so I planned on working for this little Lego. I was going to teach kids to program with Legos at a summer camp, which sounded cool, but it didn't pay that well, and I was just going to do it in Berkeley. And so I had already set to move to Berkeley, and then I got the call from PG&E, and I was so excited. And so I'll give you guys a few tips on how I ended up getting the call. The most important part, obviously, is the resume. I mean, these days, cover letters aren't that important. They really look at your resume. And so with the tech resume, it's different than a normal resume that you're going for a job. The number one thing you list on the tech resume is what classes you're taking and what classes you have taken. So I listed GPA, I listed where I'm from and what major I am, etc. And I listed what classes I'm in right now with a description of each one. I can give you all the template to the resume. I'll write my email up too so you can see this template. And then I wrote at the very bottom a very short line of what I have taken, the experience I have, and then work experience, to prove that you're a reliable person, you've had a job before, and then personal projects, which are very important, just a very vague description of personal projects. And so I got this call, and he gave me a phone interview right away. He said, "You have an amazing resume, it's actually the best one I've ever seen, and so I'm going to give you this phone interview right now." And he asked me 6 questions. Maybe 6 to 10, pretty basic ones. It wasn't like a crazy tech interview. I just got the job. Because I later found out in PG&E or in most big companies today, the internship is the new interview. They're not wasting time with talking to you face to face, because it's really important to an interview to talk well. You can know all you want, but you have to be able to converse well with this person and prove that you can work on a team. And so the internship itself, you know, it's cheap, it's inexpensive to hire interns, especially for a big Fortune 500 company. And so they're going to test you and see if you get along with the company, and then they'll hire you. And that's the real like process these days. And so I wrote down a little thing what I'm going to talk about next. So I got the job, and that was awesome. And so PG&E specifically, a lot of Fortune 500 companies, they're composed of a lot of older individuals, and so 40% of PG&E's workforce is retiring in the next 5 to 10 years. And so they're on a hunt for like people like us, and a lot of companies are like that. And so they hired 200 interns last summer. Now this summer is 300 interns, and I was lucky enough to get Spencer Bashville, one of them. And so that's awesome. And so like it begins with, you get there, and you're in San Francisco, and you meet a group of interns, and you go on a scavenger hunt. So I mean, this first week is just like fun. You know, you're gonna get paid really well, and you're just having fun. And like you go and meet all the interns. You have like this big intern Olympics, and you just play games. So the first week it's like, this is amazing. You know, I'm in San Francisco and I'm doing all this stuff. And then the real work happens, right? You get assigned to a project. And so the way projects work, at least for the internship that I was in, it was like, here's your project, and I was doing database work. Like, if you guys have ever taken 355 with Haterman, essentially, I didn't take that class at first, but that's the whole work, is doing that. You're learning how to develop I had to learn how to develop a back-end website with ASP.NET, which is a framework, and then C# as the back-end language. And so I learned all of that on the job. Like, they don't expect you to know all of this crazy material right away. They're expecting you to learn and to like get used to the company and see how you work with all of these people that have been here for a long time. And it's a lot of networking. You have to talk to a lot of people. And so I learned a lot. I mean, the second week, after all the fun games, it was like, all right, just learn. You know, research for a whole week or two, touch up, and then come back to us when you feel like you're comfortable with what you should be doing. I did it completely wrong in the beginning. I had no idea what I was doing. I was an idiot. And like, I did no backend because I didn't even know how databases worked. And so it was like a weird static HTML web page that would like just compile something from like a system queue like every day. And it was weird, and like I had no idea how that worked, and eventually converted it into this backend database magic that real dynamic websites are based on today. And like internships are flexible, and so they're flexible, and so like you need a day off, right? It's like, all right, you can have the day off, but you have this deadline. It's like, okay, it's like, oh, I can't do this today. Well, remember, your deadline is this, and you have to turn in the project to the end. So it's super flexible. You can work from home if you need to. You know, there's, as CS majors, it's like you don't have to show up every day if you're on task, and they know that I went every day or so. But they're really flexible. It's awesome working in the CS field. And working with for like a Fortune 500 company, I highly recommend because you get a lot of benefits. Like they sent us all to a Giants game for free, and they paid us on the clock while we're watching this Giants game, and it was really cool. You get a lot of cool like perks like that. Like I wouldn't trade it for anything. And there's benefits working in startups too. Startups are awesome because your environment is with a whole bunch of cool people your age, and there's probably beer on tap, and there's probably like awesome things for you to do there. PG&E is different, but I got to work in this giant like 30-story building and overlooking like the Bay Bridge. It was cool. But highly recommend startups. My brother did that, and I was into security, but still a lot of growth. And so, I mean, the main thing I want you guys to know is that, yeah, don't be afraid to apply, because like you don't need to know everything right now and then get this internship. The internship is for students. You know, you're going to be a senior, or you're going to be a super senior like me. Like this is my 5th year, and I'm doing it again because I'm coming back for the 5.5 years. It's really lame, but it happens. And so, just like apply everywhere, and don't be afraid to get the interview, because you're probably going to get it, and you're going to learn a lot on the way. So just be confident, and that's what I want to leave you guys with. Questions about how I did it?
So you said you got called back. Are you go permanent, or?
I mean, I hope so. So if I go in the second time round, I'm going to be like, okay, I'm ready to join this.
Second time for the internship?
Yeah, this is my second internship this summer. Different field. I'm doing mobile development, which sounds really awesome because I'm in Objective-C programming right now, and I think it's iPhone. They haven't given me complete specifics, but mobile development, I'm assuming I'm going to be doing phone development, so I'm pretty excited about that.
Questions?
Thank you, guys.
All right, that concludes our session for today. Please come back a week from today. We have 2 more presentations, and of course, that's going to also be end of semester celebrations. Come back, please. Thank you.